Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on CO2 sequestration simulation in CMG software. We are going to use GEM as the simulation machine, and we are still in topic of solubility trapping. Okay, if you watch the previous videos, we have constructed the CO2 storage, which incorporate, of course, the structural trapping and hysteresis or residual trapping, and we also include the solubility trapping. But on previous case of solubility trapping, for the Henry's law constant correlation, we use Lingham's method. Okay, there is another method actually that will help us to generate the Henry's law constant correlation, and we will use Harvey's method. Why is Henry's law constant correlation important? Yeah, don't forget we are talking about solubility. Okay, so in order to activate the solubility, we must incorporate Henry's law. Okay, Henry's law is about mass transfer, and solubility is about mass transfer as well. In this case, mass transfers from the CO2 in the free phase into the aqueous phase. Okay, so previously we construct the, you know, we construct the fluid model, of course, using Windprop. So here, this is the original dot depth for the Windprop, which apply the Lingham's method. So I'm going to copy and paste. Okay, and then I think this one, I'm going to, can I rename it? Yes. Solubility, let's say I'm going to call this Harvey, like this. Okay, so we are going to apply Harvey's method. Okay, so Windprop underscore CO2 injection base case in this case means the structural trapping. Okay, and there is no, you know, there is no change in Windprop to enable residual trapping. So a change only appear to accommodate solubility trapping. That's why the naming is just best case plus solubility. Okay, but now the solubility, we are going to use Harvey's method. So just drag it to Windprop. All right. Okay, so this is the Windprop. We are inside the Windprop now. And now in the command line, I'm going to call this solubility Harvey. Okay. Okay, we still use Peng Robinson 1978, and for the unit kilopascal and degree centigrade, and the feet in mole, okay, just basic. And then let's go to component selection. Just to remind you, we include, of course, the CO2 in our fluid model and this CH4, the methane, okay? And this is the physical properties, including critical pressure, critical temperature, eccentric factor, molecular weight, right? And others. Okay, so now we are going to select aqueous phase. Okay, and here for the Henry's law constant correlation, we applied Lingham's method in 1986. Okay, in this case, we are going to change to Harvey's method, which is a newer correlation. Okay, it's in 1996. Okay, and it's very easy. I just select this Harvey's method 1996. CO2 options, modified CO2 Henry's law constant, no. Temperature dependent, not yet. And regarding H2S, if we accommodate H2S in our fluid model, modified H2S, Henry's law constant, if you want, temperature dependent, okay. Right, so in this exercise, we just change from Lingham's to Harvey's method. Okay, and that's it. I already create a new file. Okay, so I just now just save current dataset. Okay, so now I will open the Windprop gem in text. Okay, so let's go to the CMG. Wait, or not yet. We need to run first. Run simulation. Okay, so this is, yeah, the run has been completed. Of course, it's very fast. Simulation output here. Okay, you can see the result and the graph. Okay, and yep, here. Just to review Windprop, this is the name Windprop CO2 injection base case. And then this is the number of component name, right? Okay. And then critical pressure, critical temperature, omega A, omega B, specific gravity, composition, okay, and solubility, okay. All right, yeah, just to check Harvey, and then, yeah, this is just component property plot, composition, simulation result, event log, simulation output, right? Okay. All right, so let's go to the CMG first. Okay, so now within this, the CMG, we have Windprop CO2 injection base case solubility Harvey.gem. Okay, so .gem. Previously for the Windprop file, it's .dat, but after we run, we created the .gem. Okay, so let's open it or maybe edit. So edit will show up in Notepad. Okay, so this is inside the .gem. The following is the fluid component property data in gem format. The unit system and fluid composition should be specified in the input-output control section. The units and composition specified in Windprop are included here as comments for informational purpose. So everything here, the result, again, we see the critical pressure, critical volume, critical temperature, eccentric factor, molecular weight, binary, volume shift, right? And here, so we have now the new, after we use Henry's method, Henry's method, we have solubility and Henry's correction for the CO2. Okay, so now what we are going to do is we will copy this one again. So we are going to copy this and we will paste this code, solubility and Henry's correction CO2 in the .dat. Okay, in the .dat. .dat for the, not for the .dat for the Windprop, but .dat for the dynamic simulation. Okay, again, it's not .dat for the Windprop, but .dat for the builder. Okay, not the Windprop, but the builder. But be careful, we are going to copy only for the CO2. We will not copy the parameter for the C1. Okay, so yeah, copy this and we will go to the .dat for the builder. Okay, so let's go there. Okay, so if I'm not mistaken, this is the file, the builder file, which includes hysteresis and solubility. So I'm just going to copy and paste. Okay, and then Let's rename it as with Harvey. Okay, and then just open. Okay, and we are going to find the keyword for solubility. Sorry. Okay, there you go. Okay, so solubility here. We are going to replace this with the new keyword, okay, which we get from the Windprop with Harvey method. Okay, so let us go back to take the keywords from the Windprop. Okay, so this one, solubility, and copy this, Henry correction CO2. Copy this one. Okay, let's copy this one, make sure. Okay, and copy this in place of the solubility keyword in this previous dot. Okay. Okay, and then just save. Okay, and all right, we already used the Harvey in this case. So after we save, and then of course, yeah, don't forget to change the title. We can run it on the gem, and later we will check the results. Okay, so I'm going to run this into the gem. Okay, so here, all right, I just drag it and then drop it to gem. Okay, submit run the simulation job, number of processor 4. Okay, so just click on OK. All right. And later we will, compare the result from Lingham's method and also the Harvey's method. Okay, so let's open the result. Okay, so if you want to check the result from the gem, you can find it in the .out. Okay, the extension is out. If you want to open the result visually in the results feature in the gem, then you go to SR3. But if you want to check the result in terms of the writing, then you find the .out. So let's check the result, the .out, this one. CO2 injection hysteresis solubility. We obtain this one using Lingham's method. So let's just click on open. Okay. And then let's find the CO2 storage there. Okay, so the result is here. So the supercritical phase in moles and in kilogram, you see here, the trap here, and the CO2 dissolved in water is here. Interesting. Okay, and we will keep it, and let's just check also the result from Harvey's method .out, this one. Okay, double click, and again check the dots, the CO2 storage, and this is the result. Okay, let me squeeze it as well. Sorry, yeah, there. Okay, and then let's find this one. Okay, so this one is using Lingham's method, and this one, the right one, is using Harvey's method. So you can see the result is, the result is pretty much closed. It can be observed that the results from the two solubility methods are quite similar. Harvey's method uses a correlation to estimate Henry's constant. Again, Harvey's method use a correlation to estimate the Henry's constant, which is more suitable to cases where there are thermal effects in the model. Okay, so again, if there are thermal effects on the CO2 storage operation, then it is better, it is recommended, at least CMG recommends you to, using the Harvey's method. Okay. Okay, since that's not in the case here, the results don't vary vastly between the two models. Okay, in our current exercise, there is no thermal effect, so there is no big difference between the Lingham's method and Harvey's method. Okay, and of course, if you want to visually show the result from Harvey's method on the result CMG, you can do as well, but just by looking at the numerical value, the visualization will not, will not differ significantly. Okay, so I'm just going to close this case here. So in terms of solubility trapping using Harvey's method, we are done, and we will move forward to the next case. God willing, we will try to do, we will use basic solubility trapping with Harvey's method, and we will apply infinite acting reservoir. Okay, but until then, see you later, and thank you so much for watching. Thank you.